3 cabins, 6 years, every single one of them failed. Not slowly, not gracefully. They failed the way things fail in Alaska, violently, completely, and without warning. The first one, I built with my hands and everything I knew. I was proud of it. I'd spent months studying cabin construction, watching videos, reading books. I thought I understood what I was doing by the third winter. The foundation had shifted so badly that the front door wouldn't close. The floor had buckled. There was frost growing on the inside of the walls, not condensation. Actual frost spreading across the logs like something alive. I'd heat that cabin for 8 hours straight and still wake up at 3 a.m. able to see my breath. I tore it down myself. That was almost worse than watching it fail. Then I built a second one. Smarter this time. Or so I told myself. I'd fix the mistakes from the first. New foundation approach, better roof pitch, different log species. And for about 18 months, I thought I'd cracked it. I thought I finally understood what Alaska needed. Then came the snow year. You have to understand, Alaska doesn't snow the way other places snow. When a real winter hits certain parts of this state, you're not dealing with a foot or two on the roof. You're dealing with the kind of accumulation that bends structural lumber, the kind that collapses outbuildings overnight. My second cabin survived, barely, but the damage to the roof system was so extensive that repairing it cost more than starting over. So I started over. Third cabin. This time I brought in help. Hired a guy who'd built in Alaska his whole life. We took our time. We did it right. And it was genuinely good, well-built, solid, beautiful even. A real log cabin in the wilderness. The kind of thing you see in photographs and feel something about. It lasted 4 years before the rot started. Not surface rot. Deep rot. The kind that gets inside the log before you see any evidence on the outside. By the time we found it, 3 of the main structural logs were compromised. The moisture had found a way in through a vapor barrier mistake I hadn't even known I was making. We'd sealed the cabin so carefully from the outside that we'd trapped the moisture that was already inside. The logs had been slowly composting for years. That's when I stopped. That's when I sat down in the snow outside what was supposed to be my best work, and I asked myself a question I should have asked 6 years earlier. What if I'd been solving the wrong problem? Because here's what nobody tells you about building in Alaska. The dream and the reality are completely different animals. The dream is a handcrafted log cabin with smoke curling out the chimney, surrounded by spruce trees, totally self-sufficient and beautiful. That dream is real. Those cabins exist. But what also exists is the permafrost underneath them, and the freeze-thaw cycles attacking them, and the moisture trying to get inside them, and the snow trying to crush them, and the settling and the shifting and the cracking that happens when you put organic material into one of the harshest environments on Earth and ask it to hold still. I've been fighting Alaska. I needed to stop fighting and start listening. So let's go through every mistake, every single one. Because if you're thinking about building anything in this state or anywhere with serious winter, these aren't hypothetical warnings. These are the specific things that will end your project, cost you everything you put into it, and send you back to square one, exactly the way they sent me. Mistake 1. The foundation. This one kills more Alaska builds than anything else, and it kills them slowly enough that you don't realize what's happening until it's too late. Permafrost is not just frozen ground. It's not something you can pour a concrete slab over and forget about. Permafrost is a living system. It responds to heat. The moment you put a heated structure on top of permafrost, you start thawing it, and as it thaws, it moves. It shifts, it drops in some places, and pushes up in others. Geotechnical engineers call this differential settlement. I call it the reason my first floor looked like a wave after 2 winters. The fix is not a bigger slab. The fix is not more rebar. The fix is elevating the structure off the ground entirely on pilings driven deep enough to hit stable material, or accepting that you need to thermally isolate the floor so aggressively that you never transfer heat to the ground below. Most people don't do either. They pour a conventional foundation, because that's what they know, and Alaska eats it. Mistake 2. The roof. Pick up a single cubic foot of dense wet snow. Feel how heavy that is. Now imagine that weight multiplied across every square foot of your roof. In parts of Alaska, design snow loads exceed 300 pounds per square foot. That is not a typo. 300 pounds per square foot. A typical residential roof in the lower 48 is engineered for maybe 20 to 40 pounds per square foot. You bring that structure to Alaska, and a bad winter doesn't just damage it, it ends it. My second cabin's roof was overbuilt by normal standards. It wasn't overbuilt by Alaska standards. The ridge beam deflected. The rafters cracked at the bird's mouth cuts. The whole system racked slightly to one side. We caught it before total failure, but only because I was checking the structure obsessively that winter. Most people aren't up there with a flashlight at midnight during a storm. Most people find out in the morning when something has already given way. If you're building a pitched roof in Alaska, you need a structural engineer who has actually worked in Alaska to sign off on your load calculations. Not someone who's looked at the state's building codes online. Someone who has seen what these winters do. Mistake 3. The vapor barrier. This one is invisible until it isn't. Moisture in Alaska doesn't behave the way it behaves in moderate climates. The temperature differential between inside and outside in deep winter can exceed 100 degrees Fahrenheit. That differential creates an enormous vapor pressure, essentially a force pushing warm, moist interior air outward through any gap in your building envelope. If that vapor hits a cold surface before it exits the structure, inside the wall assembly, inside the log itself, it condenses, it freezes, it melts. It creates liquid water inside your walls where you will never see it and never feel it until the damage is already done. The counterintuitive mistake I made was putting my vapor barrier in the wrong place. I'd sealed the exterior beautifully, but by not creating a continuous vapor barrier on the warm side, the interior side of the insulation, I'd essentially invited moist air into the wall assembly and then trapped it there. The exterior seal prevented it from drying to the outside. The result was slow, invisible, catastrophic. The vapor barrier goes on the inside, the warm side. Every penetration, every outlet, every seam gets sealed. This is not optional. This is not a detail. This is the difference between a cabin that lasts and one that quietly destroys itself from within. Mistake 4. Log settling. Green logs move. Everybody who builds with logs knows this. What most people don't appreciate is how much they move, how long they move, and what happens to everything attached to them while they're moving. A green log wall can settle several inches over the first few years. Several inches. If your window and door frames are rigidly attached to that wall, they will rack, they will twist, they will bind. And in Alaska's cold, the tolerances are even tighter, because the wood is also contracting thermally at the same time as it's settling structurally. I built my doors and windows in summer. They fit perfectly. By February of the first year, 2 of the 3 doors required a shoulder to open. By February of the second year, one of them wouldn't open at all without a pry bar. We're not talking about minor sticking. We're talking about a door that had become structurally locked in its frame. The fix is slip joints. Every window buck, every door frame, every interior partition that touches an exterior log wall needs a float to be mechanically isolated from the settling wall in a way that allows vertical movement without transferring that movement to the frame. This is standard in quality log construction. It was not standard in mine. Mistake 5. Heat source placement. A wood stove in the corner feels cozy. It is not efficient. Cold air in a structure doesn't mix readily with hot air. It stratifies. The hot air rises to the ceiling near the stove, while the floor away from the stove stays cold. In a small cabin, this is uncomfortable. In an Alaskan winter, it becomes dangerous. I have woken up in my own cabin, 6 feet from an actively burning stove, and found the temperature near the floor on the far wall was below freezing, inside the cabin, while the stove was going. Central placement changes everything. A stove positioned in the center of the living space, ideally elevated slightly to improve radiant distribution, with a thermal mass around a store and slowly release heat. That is a heating system. A stove stuff in the corner, because its outer way is just a campfire you're paying for in firewood. Also, no single heat source. Ever. In Alaska, you need redundancy. A backup propane heater, a second wood stove, something. A primary heat source failure at -40 is not an inconvenience. It is a survival situation. Mistake 6. building in the wrong season. Alaska has a building window. It is short and it is unforgiving, and ignoring it costs you everything in extra labor and compromised results. Frozen ground cannot be excavated with normal equipment. Concrete cannot be poured below certain temperatures without additives and heating equipment that dramatically increases cost. Wood doesn't accept fasteners the same way in extreme cold. Adhesives fail. Sealants don't cure. And the human doing the work, numb hands, shortened days, brutal conditions, makes more mistakes per hour than he would in August. I started my third cabin in early spring, thinking I was getting ahead of the season. The ground was still frozen 2 feet down. We spent the first 3 weeks doing work that should have taken 4 days. We burned through 2 generator fuel tanks, just keeping the work site warm enough to function. We compromised on 2 details I knew we were compromising on because stopping and waiting wasn't a real option by that point. We were committed. Build in summer. Plan in winter. Use the cold months for design, material sourcing, site prep planning. Everything except physical construction. The moment the ground breaks, be ready to move fast. That window closes faster than you think. Mistake 7. Overbuilding complexity before the basics work. This one is about ego. I'll say that plainly because it was my problem, and it's the problem of most people who've done enough building to be dangerous. By my third cabin, I was competent. I knew joinery. I understood structural principles. I wanted to build something genuinely impressive. So I added complexity, decorative log work at the gable ends, custom-fitted stone at the foundation, elaborate interior timber framing that required precise cuts and long installation times. Meanwhile, the vapor barrier was wrong. The foundation approach was still imperfect. The heating was still a single-point system. I was adding beautiful details to a structure that had fundamental problems I hadn't solved yet. It's the building equivalent of painting a car with cracked engine block. Get the envelope right. Get the foundation right. Get the heat system right. Make it boring and functional and survivable. Then, once it's proven through a full winter cycle, start adding the things that make it beautiful. Not before. Now, after all of that, after 6 years and 3 failed structures and more money than I want to say out loud, I found myself standing in the snow looking at a photograph of something that looked nothing like a cabin, a Quonset hut. My first reaction was no, absolutely not. This is Alaska, not a military base. I came here to build something real, something with character, something that looks like it belongs in this landscape. A corrugated steel arch looks like it belongs in an industrial park. I spent 2 weeks telling myself no, and then I started doing the math. Time to erect a Quonset shell, a real one, properly sized, a few days with 2 men. No specialized skills required. The arch panels bolt together with standard hardware. The design is essentially foolproof because there are almost no design decisions left to make. It's an arch. The arch is the structure. And then I thought about snow. An arch sheds snow, not because you shovel it, not because you've engineered the pitch correctly, because physics. The curved surface has no flat plane for accumulation to build on. The snow that lands on a Quonset hut slides off continuously. The load problem, the problem that nearly ended my second cabin, does not exist in the same form. The structure is inherently resistant to the thing that Alaska uses to destroy everything else. No settling. Steel doesn't shrink and expand the way green logs do. There are no slip joints to engineer, no seasonal adjustments to make, no doors that bind in February. The geometry is fixed. What fits in summer fits in winter. Spray foam insulation on a curved interior surface is, counterintuitively, easier than insulating a conventional framed wall. The foam bonds directly to the corrugated steel, fills every irregularity, and creates a continuous air and vapor barrier in a single application. The vapor barrier problem, the invisible killer of my third cabin, is solved as a byproduct of the insulation process. Build time. This matters more than almost anything else in Alaska. The window for construction is short. A Quonset shell goes up so fast that you're spending the majority of your good weather window on the interior. The finishing, the systems, the details, rather than fighting to get a structure closed before the weather turns. Speed is not just convenience here. Speed is structural quality. because rushing to close a structure before winter arrives is where most of the critical mistakes happen. And the cost, compared to 3 failed cabins, compared to the labor and materials, and wasted time of starting over twice, the Quonset is not cheap, but it is dramatically cheaper than being wrong. Now I'll tell you what the Quonset gets wrong, because it gets things wrong. Condensation management is genuinely harder. If the spray foam application is incomplete, if there are voids, if the steel is exposed anywhere, you'll get condensation on those surfaces in winter. It beads, it drips, it creates moisture problems that are different from log cabin moisture problems, but equally destructive. You need a professional foam application, done right the first time, or you will chase condensation issues for years. The aesthetic is what it is. I've made peace with it. Some men haven't and won't, and that's a legitimate position. If the look of the structure matters to you, if the whole point is a handcrafted wilderness cabin experience, the Quonset will never satisfy that. You can finish the interior beautifully. You can add a timber-framed entry vestibule. You can do a lot to make it feel warmer and more intentional. But the outside is always going to look like what it is. Permitting varies wildly by region. In some parts of Alaska, a Quonset hut on private land requires nothing. In others, the non-standard design creates friction with building departments that are used to conventional structures. Know your local requirements before you order anything. And finally, when does a traditional log cabin still make sense? When you have time, when you have the specific Alaska-adapted knowledge to build it correctly from the start, when the permanence and aesthetics matter more than efficiency, when you're on land with no permafrost issue and a manageable snow load, it is not an inherently wrong choice. It is a choice that demands a level of expertise and Alaska-specific knowledge that almost nobody arrives with. I didn't arrive with it. I earned it by failing 3 times. Here are the numbers you actually want. First cabin, 14 months of primary labor, approximately $38,000 of materials, lasted 3 winters before being torn down. Second cabin, 8 months of labor, $29,000 of materials, roof damage in year 2 cost $11,000 to partially repair before we abandoned it. Third cabin, 11 months of labor, $52,000 of materials, including outside help, for years before rock compromise made it unlivable. The Quonset, shell erected in 4 days, total project, including insulation, interior finishing, heating system, and foundation. 6 months of work, $41,000. It has now been through 3 Alaska winters. The door opens the same way in February as it does in August. The floor is level. There is no frost on the interior walls. The roof has never been shoveled. That is not an advertisement. That is a result. 6 years, 3 failures. 1 lesson. Alaska will always win if you fight on its terms. The only move that works is changing the terms of the fight. Whatever you're planning to build out here, take the information in this video seriously. Not as theory, as the specific cost of ignoring it, paid in real money and real years by someone who did exactly what you might be about to do. Build smart. Build once.